For as long as humanity has looked at the night sky, we have asked the same question. Are we alone? Not just in the universe, but in the conditions that made life possible. Is Earth unique, or is it simply one example of a pattern repeated across the stars? One distant planet has quietly challenged that idea. This is Kepler-62f, a world many scientists call one of Earth's closest cosmic cousins. Kepler-62f was discovered by NASA's Kepler Space Telescope, a mission designed to answer a single profound question. How common are Earth-like planets? For years, Kepler stared at one small patch of sky, watching thousands of stars for tiny drops in brightness. Each drop was a possibility, each shadow a planet. Among thousands of discoveries, Kepler-62f stood out, not because it was extreme, but because it was familiar. Kepler-62f lies about 1,200 light-years from Earth, in the constellation Lyra. It orbits a star smaller and cooler than our Sun, but brighter and more stable than many red dwarfs. Its year lasts about 267 Earth days, placing it comfortably within the star's habitable zone, the region where liquid water could exist on a planet's surface. Kepler-62f is only about 40% larger than Earth. That may not sound like much, but in planetary terms, it matters greatly. This size suggests a rocky composition, not a gas giant. It could have mountains, valleys, continents, and possibly oceans. Among thousands of exoplanets, Kepler-62f remains one of the best size matches to our home world. Kepler-62f receives less energy from its star than Earth receives from the Sun. This means the planet may be cooler than Earth. If it has an atmosphere rich in greenhouse gases, it could trap enough heat to maintain liquid water. If not, it may be a frozen world, an Earth-sized planet covered in ice. Either way, Kepler-62f occupies a delicate balance between warmth and cold. Atmospheres change everything. They regulate temperature. They protect surfaces from radiation. They allow water to exist. We do not yet know if Kepler-62f has an atmosphere. But if it does, even a moderately thick one, it could transform the planet into a stable, habitable environment for billions of years. Without an atmosphere, the surface would be silent, frozen, and barren. Because Kepler-62f orbits relatively close to its star, scientists believe it may be tidally locked. One side always faces the star. The other remains in darkness. At first, this sounds hostile, but climate simulations suggest that if an atmosphere exists, heat could circulate around the planet, preventing extreme temperature differences. Between day and night, a broad temperate zone could form, a region where conditions remain stable for life. Life on Earth began simply, in water, protected from radiation. Given time, Kepler-62f may offer similar opportunities. Not forests or cities, but microbes, slow chemistry, and biological beginnings. Life does not need perfection. It needs stability, and Kepler-62f may have had billions of years to provide it. Kepler-62f matters because it shows us that Earth is not alone in its category. Planets of similar size, in similar orbits, around stable stars do exist. They may be far away, but they are not rare. Each discovery like Kepler-62f makes the universe feel a little less empty. Kepler-62f does not roar with fire. It does not hide beneath endless storms. It simply orbits, quietly, steadily, around a distant star. Somewhere in the galaxy, an Earth-sized world may be waiting beneath alien skies, experiencing seasons, weather, and time. This is Kepler-62f, the true Earth cousin that reminds us how familiar the universe might be.